the whys and the wherefores.
The idea here is that the egg should get into the bottle of its own accord, and after a certain amount of preparation, the trick works. Here's the whole thing again in slow motion.
What's the explanation? Warming the bottle causes the air inside it to expand. It escapes. When the flame goes out, the remaining air cools down and contracts. The result is a partial vacuum inside the bottle. The pressure of the air outside forces the egg into the bottle because on the underside of the egg, the air inside the bottle offers hardly any resistance. The things needed here are a match, a little spirit on cotton wool, and a boiled shelled egg.
The fact that the air really does press the egg into the bottle can easily be demonstrated. The air inside the bottle is warmed up again. It expands. When the flame goes out, it cools down and contracts again. You can see how the rubber skin stretched taut over the bottle opening is forced in by the outside air which is pressing down. This pressure can be so strong that the balloon skin splits.
Air pressure, atmospheric pressure that is, fluctuates. This barometer shows the atmospheric pressure. Under a hermetically sealed glass dome, there's air at normal atmospheric pressure. If the atmospheric pressure changes, here it's being done by our vacuum pump, the barometer's sensitive diaphragm bulges out or caves in. These movements, which indicate fluctuations in atmospheric pressure, are conveyed to a pointer so that they can be read off on a graduated dial.
What happens in the glass dome is the same thing as you see here with the expanding air in the bottle. As the pressure of the surrounding air drops, the balloon is inflated.
Even water can be held in a glass by atmospheric pressure. A good trick.
The water in the glass presses on the cardboard and the surrounding glass walls. The external air pressure does the same. With this amount of water, the air pressure is greater than the water pressure. But if the force produced by the weight of the water is greater than the force of the air pressure, the experiment doesn't work.
This measuring instrument shows fluctuations in temperature and atmospheric pressure. A diaphragm reacts to these. Depending on how the temperature and pressure conditions alter, the diaphragm expands, as we saw just now with the barometer, or contracts. Via a mechanism, a clock is wound up by this means, all of its own accord.
The air in two hemispheres is evacuated through a tube which is connected to a pump. The surrounding air presses so hard on the hemispheres that they can't be pulled apart, not even by this weight.
You can try out something similar at home using these sink plungers. Needless to say, it doesn't work the first time. But now the air is pressed out of the rubber suction cups, and the pressure of the surrounding atmosphere holds the suction cups together, quite strongly in fact.